Everyone is racing to adopt AI. Very few are ready to operate it. That's why the same pattern keeps repeating. Impressive demos, then untrusted outputs, then a sudden cost spike, then security and compliance panic, and finally a pilot that pauses and never comes back. The system didn't collapse because the model was weak. It collapsed because the enterprise had no operating discipline behind it. In this episode, the focus is a 3 to 5 year playbook. Who owns truth? Who absorbs risk? Who pays? And what gets enforced? Stop asking what AI can do. Start asking what your enterprise can safely absorb. The foundational misunderstanding: AI is not the transformation. Most organizations treat the AI platform as the transformation. They are wrong. Architecturally, AI is an accelerator. It does not create structure. It magnifies whatever structure already exists: your data quality, your identity boundaries, your decision rights, your exception culture, your cost discipline. If those are coherent, AI makes the enterprise faster. And if they're not, AI makes the enterprise loud and expensive. This is the foundational misunderstanding. Leaders think the transformation is adopting AI, meaning licensing models, standing up a platform, hiring a few specialists, and launching pilots. In reality, the transformation target is the operating model that sits underneath decisions. Because AI isn't a tool that sits on the edge of the business. It becomes part of the decision loop. And the decision loop is where enterprises either create value or create incidents. Here's why pilots look so good. A pilot is a small controlled experiment. It runs on a narrow slice of data. It has a friendly audience. It uses a curated document set. It usually has an unofficial exception stack. Temporary access granted just for the demo. Missing classification because we'll fix it later. Relaxed policies because it's not production. And a lot of manual cleanup that nobody writes down. That's not innovation. That's conditional chaos. And it works briefly because you're operating outside the real system. Then you try to industrialize it. Production is where scale forces every hidden assumption to become explicit. Suddenly the model is exposed to conflicting meanings, missing owners, drift in access, and data that has never been held to a consistent semantic standard. The same question gets two correct answers depending on which dataset or document the system retrieved. The model doesn't know it's inconsistent. It just synthesizes confidently. And this is where executives misdiagnose the failure. They blame the model. They blame hallucinations. They blame the platform. But the system did exactly what you built. It produced outputs from ambiguous inputs under undefined accountability. AI doesn't leak data accidentally. It leaks it correctly under bad identity design. AI doesn't create wrong answers randomly. It produces wrong answers deterministically when your enterprise cannot agree on truth. That distinction matters. So the useful split is not AI tools versus no AI tools. The useful split is the innovation stack versus the operating system. The innovation stack is what most organizations already know how to fund. Experiments, pilots, proof of concepts, hackathons, labs. It's optional, it's exciting, it's also disposable. When it fails, you shrug and move on. The operating system is different, it's durable, it's owned, it has guardrails, it has budgets, it has accountability, it has enforcement, it's boring on purpose, and AI belongs to the operating system category. Once AI participates in decisions, you're no longer deploying a feature, you're deploying a decision engine that will run continuously at scale across the organization with a failure mode that looks like trust collapse. That means the first executive decision is not which model are we using. The first executive decision is who owns truth. Second, who approves access for AI and for how long. Third, who carries the cost when usage spikes. Because those are not technical questions. Those are funding, risk, and accountability decisions. And they last 3 to 5 years, regardless of which vendor wins the model race next quarter. This clicked for a lot of platform leaders when they watched the same pattern happen in cloud. Cloud didn't fail because the services weren't capable. Cloud failed when organizations treated it like a procurement event instead of an operating model shift. They bought capacity, migrated workloads, and assumed governance would arrive later. Then drift happened. Exceptions accumulated. Costs surprised finance. Security found gaps after the fact. The platform team became an incident response unit. AI is the same failure pattern, but faster. Because AI is probabilistic output sitting on top of deterministic controls. If you don't enforce the deterministic layer, identity, data governance, semantic contracts, cost constraints, you will get probabilistic enterprise behavior. Nobody can explain it. Nobody can predict it. Everyone will blame someone else. Now here's the pivot. If the transformation target is decisions, then data becomes the control surface. Not dashboards, not warehouses, not lake migrations. Data as the control surface, definitions, lineage, access, quality, and cost attribution, all tied to a decision that someone is accountable for. Once you see that, the platform stops being a tool set. It becomes your operating model. And if you're a CIO, CTO, or CDO, this is the uncomfortable truth. The only way AI scales safely is if you make those operating model decisions before the pilot goes viral. From digital transformation to decision transformation. Most leaders still think in digital transformation terms: take a process, remove friction, automate steps, make throughput higher, and ideally reduce headcount pressure. That was a rational goal for a decade. But AI doesn't mainly optimize throughput. AI optimizes decisions. That distinction matters because enterprises don't fail from slow processes as often as they fail from inconsistent decisions. Different teams making different calls with different definitions, using different data under different risk tolerances. That's not inefficiency, that's entropy. Digital transformation asks, can we do the same work faster? Decision transformation asks, can we make the same decision better, faster, and consistently? And better has a real meaning here. It means the decision is based on trusted inputs, the semantics are understood, and the accountability is explicit. It also means the decision has a feedback loop so the enterprise can learn when it was wrong, because AI will make the wrong decision sometimes. That's not a scandal, that's mathematics. The scandal is when nobody can explain why it was wrong, nobody owns the correction, and the organization keeps acting on it anyway. So if the unit of value is now the decision, every AI initiative has to answer 4 decision requirements up front. First, trusted inputs, not we have data. Trusted inputs mean you know the origin, you know the transformations, and you can defend the quality. You don't need perfect data, you need data with known failure modes. Second, define semantics. The thing most people miss is that data quality problems are often semantic problems wearing a technical disguise. 2 systems can both be accurate and still disagree because they mean different things by the same word. Customer, revenue, active, closed, incident, risk. Those are political nouns with budgets attached. AI will not resolve that ambiguity. It will learn it, and then it will scale it. Third, accountability. Every decision needs an owner, not as an abstract governance concept, but as an operational fact. When the output is wrong, who is accountable for the correction? Who owns the business rule? Who owns the data product? Who owns the access policy? If the answer is the platform team, you've already lost. They can't own your business reality. Fourth, feedback loops. Decisions without feedback loops are just outputs. Outputs don't improve. Outputs drift. Feedback loops are how you turn AI from a demo into a controllable system. Capture exceptions, measure outcomes, correct data, refine prompts, retrain models when necessary, and update policies when reality changes. Now here's the part executives underweight. Decision errors compound faster than process errors. A process error might waste time. A decision error creates downstream decisions that are now built on the wrong premise. It infects other systems: pricing, inventory, compliance, customer experience, risk. You don't just get one wrong answer, you get a chain reaction. That's why AI raises the cost of poor data design. It doesn't hide it. In the old world, bad data slowed reporting. In the AI world, bad data drives action. The error becomes operational, and operations don't tolerate ambiguity for long. This is where Azure and the Microsoft ecosystem become relevant in a non-brochure way. Azure AI, Fabric, OneLake, Purview, Foundry, Entra, these are not services you can turn on. They are surfaces where decision transformation either becomes governable or becomes conditional chaos at scale. If your enterprise treats them as an innovation stack, you'll get impressive pilots that can't be defended. If your enterprise treats them as an operating model, you'll get decision systems you can scale. So the executive framing has to shift. Stop funding AI pilots. Fund decision improvements with named owners and measurable outcomes. Pick one decision that matters. Case triage, fraud review, contract risk assessment, supply chain exception handling, customer entitlement validation. Then force the question, what data powers this decision, who owns it, what does correct mean, and how do we measure error? Once decisions become the unit of value, the platform becomes the product, not a procurement event. A product with a roadmap, SLOs, governance, and economics. And that's why the next part matters. The data platform isn't just where you store things, it's the system that makes decisions safe. The data platform is the real product. This is where most enterprise strategies go to die. They treat the data platform like a tooling migration. They pick a destination, lake, warehouse, lakehouse, streaming. They staff a project. They measure progress by terabytes moved and dashboards rebuilt. And then 3 quarters later, they announce we modernized. But nothing is modernized if the enterprise still can't agree on definitions, can't trace data lineage end to end, and can't explain why a number changed. That distinction matters. A data platform is not a place you store things. It is a capability you operate. And capabilities have owners, service levels, guardrails, and economics. If you don't design it that way, it becomes the familiar pattern, a shared utility that everyone blames and nobody funds properly. Here's the thing most leaders miss. The enterprise already treats other shared capabilities as products, even if it doesn't use that language. Identity is a product, networks are products, endpoint management is a product, collaboration is a product. If you want teams to work, you don't migrate to Teams and walk away. You operate it, you patch it, you govern it, you measure adoption and incidents, you assign owners, you budget it every year. Data is no different. If you want AI to be reliable, the data platform has to be operated like a product, because AI consumes it the way every other system does, as a dependency. And dependencies don't tolerate ambiguity. So what makes a data platform a product in enterprise terms? First, it has a roadmap, not a one-time migration. A roadmap with capabilities you'll add, standards you'll enforce, and legacy behaviors you'll retire. Second, it has SLOs, not vague promises, real operational expectations, freshness, availability of critical pipelines, time to fix for quality defects, latency for key decision datasets. If it's not measurable, it's not governable. Third, it has governance built into the delivery, not bolted on after. The platform doesn't just move data, it enforces how data can be published, discovered, accessed, and reused. Fourth, it has a cost model that maps consumption to accountability. If you can't show who consumed what and why, you're building a finance incident. Now here's the organizational failure pattern that shows up every time. A centralized data team builds a powerful platform. They do it with good intent, consistency, security, shared standards, and at first it works, then demand scales. Every domain wants their own integration, their own semantics, their own dashboards, their own urgent exception. The central team becomes the bottleneck. They get blamed for being slow. They respond by opening the gates. Self-service. And now you get the opposite failure. Decentralized teams move fast, but they become entropy engines. Everyone builds their own pipelines. Everyone defines customer locally. Everyone creates their own gold layer. And the platform becomes a catalog of competing truths. Both models fail for the same reason. They never establish decision rights. So define the roles cleanly. The platform team owns the platform capability, the shared services, the guardrails, the governance surfaces, and the operational reliability. Domain teams own data products, the data sets and contracts that represent business concepts with named owners, explicit consumers, and clear definitions. And you need both, because centralization without domains creates bottlenecks, and decentralization without standards creates scalable ambiguity. This is where a lot of data mesh conversations go off the rails. People hear domain ownership and assume it means domain autonomy without constraint. It does not. That's not autonomy, that's drift. A functional mesh has federated governance, centralized standards with decentralized execution, which means the enterprise must be explicit about what domains can decide and what they cannot. And the non-negotiables are boring, which is why they get skipped. Quality decision rights, who sets the acceptable failure mode and who funds the fix. Semantic decision rights, who arbitrates when two domains disagree about what a metric means. Access decision rights, who can approve that an AI system can read a dataset and for how long. Cost decision rights, who pays for consumption and what happens when usage spikes. If you can't answer those in one sentence each, you don't have a platform product, you have a shared storage account with better marketing. Now connect this back to the thesis. If decisions are the unit of value, then data products are the unit of control. And the platform exists to make those products publishable, discoverable, governable, and economically sustainable. That's why the next section matters. Azure's stack is not the point. What matters is which layers you make deterministic, because AI will make everything else probabilistic. Azure's data and AI stack, what actually matters? Now the uncomfortable part. Azure's advantage isn't that it has more services. Every vendor has a brochure with an infinite scroll bar. Azure's advantage is integration, shared identity, shared policy surfaces, shared governance, and a relatively coherent control plane. That distinction matters because AI doesn't fail at the model layer first. It fails at the seams, the handoffs between identity, data, analytics, and deployment. So instead of naming tools, think in strategic layers. Layers are where you make design choices that either hold under scale or decay into exception culture. Start with ingestion and integration. This is where most organizations still behave like it's 2015. They copy everything, they replicate everything, and then they wonder why costs and consistency drift. In the Microsoft world, you've got a spectrum. Data factory-style orchestration, streaming and event ingestion, and zero-ish ETL patterns like mirroring and shortcuts. The point is not which connector you use. The point is whether you've designed for one authoritative copy of data per decision domain or whether you've designed for institutionalized duplication. Duplication isn't just storage cost. Duplication is semantic divergence on a timer. Next is storage and analytics. This is where Fabric and OneLake matter, but not because they're shiny. They matter because they push you toward a unified lakehouse pattern. One logical lake, open formats like Delta, and multiple engines reading and writing the same foundation. That's valuable because it removes data movement as the default behavior, but it also removes excuses. When everything can be accessed everywhere, your governance gaps become instantly scalable. The unified platform reduces friction, therefore it amplifies weak standards faster. Then you need a semantic layer. This is where many data strategies quietly collapse. Raw tables are not truth. Tables are options. Truth in an enterprise is a governed semantic contract, metrics, definitions, relationships, and the rules for change. In the Microsoft ecosystem, that often materializes as Power BI semantic models, endorsed datasets, certified definitions, and controlled modeling practices. If you let every team invent their own measures and definitions, you don't have self-service. You have self-inflicted inconsistency, and AI will happily learn that inconsistency. Now we get to the AI lifecycle layer. This is where Azure AI Foundry matters, again, not as a place to click deploy, but as a way to standardize how models and agents get selected, evaluated, deployed, observed, and governed. The reason this works architecturally is simple. AI systems are not single components. They are dependency graphs, models, tools, retrieval, prompts, policies, data sources, and identity. A unified AI platform helps you control the graph, but only if you treat it as a governed system, not as a playground. Foundry's model catalog, evaluation, tracing, and safety controls are all useful, but they don't replace your enterprise decisions. They operationalize them, they make enforcement possible, what models are allowed, what data sources are allowed, what logging is required, what safety filters are enforced, and what observability is non-negotiable. Which brings us to the governance plane. This is the layer most executives still treat like paperwork. It is not. Governance in Azure and Microsoft's ecosystem is a set of enforcement surfaces. Entra for identity and access, Purview for classification and lineage, Azure Policy for resource constraints, Defender and monitoring systems for posture and detection, and the audit trails that let you survive scrutiny. If you can't trace data end-to-end, you can't defend AI outputs under pressure. And pressure is not hypothetical. It arrives the first time the output affects a customer, a regulator, a contract, or a clinical decision. So here's the architectural punchline. When you ask, what Azure services should we use, you are asking the wrong question. The real question is, which layers are deterministic and which layers are allowed to be probabilistic? Identity must be deterministic. Data classification and lineage must be deterministic. Semantic contracts must be deterministic. Cost controls and accountability must be deterministic. Then, and only then, you can afford probabilistic components in the decision loop because you've bounded the blast radius. If you don't, you're building conditional chaos with better infrastructure. And this is where unified platforms like Fabric are double-edged. They remove operational friction, which means teams can deliver faster. Good. But without standards and contracts, faster means you accumulate entropy faster. So the recommendation is not adopt Fabric or adopt Foundry. The recommendation is adopt an operating model that makes those platforms survivable. Because once the platform becomes easy to use, the only thing stopping chaos is enforcement. Now, if this sounds abstract, good. It means you're seeing the system. And the next section makes it concrete. Governance isn't a value statement. It's a set of non-negotiable guardrails you design into identity, trust, and semantics. Non-negotiable guardrail 1. Identity and access as the root constraint. If governance is the plane, identity is the root constraint. Not because identity is exciting, but because identity is where the enterprise decides what is allowed to happen. Everything else is downstream theater. Most organizations still frame AI workloads as tools, a copilot, a chat interface, a model endpoint, a clever workflow. That framing is comfortable, it is also wrong. An AI workload is a high-privilege actor operating at machine speed. It reads broadly, summarizes confidently, and can be wired into actions. That means you aren't deploying AI. You are introducing a new class of principle into your authorization graph. That distinction matters. If your identity model is loose, your AI system won't accidentally leak data. It will leak it correctly. It will retrieve exactly what it is permitted to retrieve. It will synthesize exactly what it is permitted to see. And when that output lands in the wrong place, everyone will call it an AI failure. It won't be. It will be an identity failure that finally became visible. So the first non-negotiable guardrail is simple. Treat AI as a privileged identity problem, not an application feature. In the Microsoft ecosystem, Microsoft Entra ID is the boundary where this either works or collapses. A lot of enterprises have a tenant strategy that can be summarized as, we have one tenant, it exists, good luck. That is not a strategy, that is an eventual incident. A tenant strategy for AI-era operating models means you decide where experimentation lives, where production lives, and how you prevent the experimental permissions from bleeding into the operational estate. Because permission drift is not a theoretical concept, it is the default state of every large environment. Once you accept that, role design stops being a compliance exercise and becomes entropy management. Every broad role assignment, every standing privileged account, every temporary access grant that never expires is an entropy generator. These pathways accumulate, and AI will traverse them faster than any human ever could. So what does non-negotiable look like here? First, you isolate privileged access. If AI systems can reach sensitive datasets, then the identities that configure, approve, and operate those systems are effectively controlling sensitive access at scale. That means you need privileged access patterns that can survive audit scrutiny and survive staff turnover. Second, you design roles for intent, not convenience. Most enterprises build roles by asking, what does the team need to do? And then granting a bundle that seems to work. Over time, those bundles expand because something broke and someone needed access. That is how the authorization surface inflates. AI multiplies the blast radius of that inflation. Third, you establish an executive decision that almost nobody wants to make. Who can authorize data access for AI and for how long? This is where governance meetings go to die because it forces an explicit ownership decision. If no one is accountable for authorizing access, then access becomes platform default. And platform default access is always broader than business intent. That means the operating model must define an approval authority for AI data access with explicit time limits. Because forever is not a duration, it is abandonment. Now here's the operational consequence. If you don't enforce these boundaries, your platform leaders will spend their lives cleaning up access drift. Not because they're incompetent, because the system will do what systems always do. Accumulate exceptions until the policy no longer describes reality. You will see it as pilots that need just a bit more access, service principles with broad permissions, workspaces shared across domains, and eventually an AI agent that can read something it shouldn't. And it will read it, reliably, at scale. This is the uncomfortable truth. Identity is not guardrail number one because it prevents bad outcomes. It's guardrail number one because it makes outcomes attributable. If you can't answer which identity accessed what, under which policy, approved by whom, you don't have control. You have hope. And hope is not an operating model. So the executive level reframe is this. You aren't approving an AI pilot. You are authorizing a new class of actor. That actor will amplify whatever access model you already have. Make it deterministic now while it's still cheap. Because once the AI system is embedded into workflows, identity redesign stops being governance work and becomes a business interruption. And that's the transition. Identity gates access, but it doesn't create trust. Trust comes from governance you can inspect, audit, and defend. Non-negotiable guardrail 2. Data trust and governance that can be audited. Trust is not a policy you publish. Trust is an operating behavior you can prove. That distinction matters because every enterprise says, we care about data quality right up until they need to ship something. Then quality becomes a future task, governance becomes a document, and the platform becomes a rumor. AI doesn't tolerate rumors. AI consumes whatever is available at machine speed, and it produces outputs with a confidence level that humans instinctively overtrust. If you can't defend the inputs, you can't defend the outputs. And when someone asks you to defend the outputs, they are not asking for your value statement. They are asking for evidence. So this guardrail is simple in wording and brutal in execution. Your data trust and governance must be auditable, not we think it's fine, not the team reviewed it. Auditable means you can answer the questions that always arrive at scale. What data did the system use? Where did it come from? Who approved it for this use? Who can access it and why? How did it move? What transformations touched it? And what version was active when the decision was made? If you can't answer those quickly, you're not operating a data platform. You are operating a liability. This is where Microsoft Purview fits, but again, not as a box you check. Purview is a governance surface, classification, lineage, and discoverability. Those three things sound like hygiene. In practice, they are prerequisites for operating AI without ending up in a shutdown meeting. Classification matters because AI doesn't distinguish sensitive from interesting. It distinguishes allowed from blocked. If you haven't labeled data, you can't enforce consistent controls across the estate. And if you can't enforce consistent controls, you will eventually ship a system that uses data it shouldn't, not maliciously, correctly. Lineage matters because you will eventually get the question, why did this answer change? In an AI system, answers change because the grounding data changed, the retrieval path changed, the semantic meaning drifted, or the prompt logic changed. If you can't trace data end to end, you can't isolate which of those happened. You can't fix it. You can only argue about it. Discoverability matters because when people can't find trusted data, they create their own. Shadow datasets are not a user problem. They are a platform failure mode. They are what happens when governance is experienced as friction instead of safety. Now, here's the governance timing law that keeps showing up. If governance arrives after deployment, it arrives as a shutdown. Because the first serious audit question, the first legal escalation, or the first customer impacting incident forces the organization to stop the system until it can prove control. Executives don't do this because they hate innovation. They do it because they can't sign their name under uncertainty. So the executive job is not to ask, do we have governance? The executive job is to ask, is governance default behavior? Default behavior means the system generates evidence without heroics. The lineage is captured because pipelines and platforms emit it. The classifications exist because ingestion and publishing require them. Access policies are consistent because identity and data governance are integrated, not negotiated. And the thing most enterprises miss is that trust is not just about whether the data is correct. Trust is also about whether the data can be used under scrutiny. You can have perfectly accurate data and still be unable to use it for AI because you cannot prove how it was obtained, how it was transformed, and who approved its use. In regulated environments, that's not a detail. That's the difference between operating and pausing. Now, you might be thinking this becomes a bureaucratic nightmare. It does if you treat governance like documentation. But governance isn't documentation. Governance is enforcement. And enforcement becomes manageable when you define the question set that every AI use case must answer before it gets promoted. What data is in scope? Who owns it? Who approved it? Who can see it? How does it move? Where is it logged? What's the retention rule? And what happens when it's wrong? This isn't for auditors. This is for operating reality. Because AI outputs will be challenged. The question is whether you can respond with evidence or with vibes. So here's the transition into the next guardrail. Identity tells you who can access data. Governance tells you what that data means, where it came from, and whether you can defend using it. But governance without a semantic layer still fails because truth is not raw data. Truth is the contract that makes raw data coherent. Non-negotiable guardrail 3, semantic contracts. Not everyone builds their own. Here's where the enterprise finally meets its oldest enemy, semantics. Not data volume, not tooling, not even governance paperwork. Meaning, semantic chaos is simple to describe and painful to live with. The same concept gets defined 5 different ways, all of them correct locally and all of them wrong globally. Customer, active user, revenue, incident, SLA, risk. Resolved. Everyone has a definition, everyone has a dashboard. None of them reconcile. And then you add AI on top and act surprised when the outputs disagree. AI doesn't arbitrate meaning, it amplifies it. The model can learn patterns, it can summarize, it can rank, it can generate. But it cannot decide which department's definition of customer is the enterprise definition. That's not a technical problem. That's a governance problem wearing a metric name tag. This is the part where leaders often reach for a comfortable phrase. We'll let teams innovate. And they do. They innovate definitions. Now you have a platform that can answer any question, but can't answer it consistently. That distinction matters because consistency is what turns outputs into decisions. If 2 executives get 2 different truths from 2 different co-pilots, the enterprise doesn't get faster. It gets suspicious, adoption collapses, then every AI project gets relabeled as not ready. It is ready. Your semantics are not. So the third non-negotiable guardrail is semantic contracts, not guidance, not best practice, contracts. A semantic contract is a published, endorsed definition of a business concept that includes the meaning, the calculation logic, the grain, the allowed joins, and the rules for change. It's not just a table, it's a promise. If you build on this, you inherit stable meaning. This is where a semantic layer becomes an operating model component, not an analytics preference. In the Microsoft ecosystem, semantic models, endorsed datasets, certified definitions, whatever your implementation looks like, are the mechanism. The important part is the governance behavior behind them. Because without governed semantics, you create a perverse incentive structure. Every domain team optimizes locally, they ship quickly, they define metrics that make sense inside their boundary, and then the enterprise tries to combine those metrics and discovers they're incompatible. That incompatibility is the real integration tax. AI makes that tax visible immediately because it cross-references, it blends, it retrieves, it generalizes, it will happily stitch together conflicting meanings and present the output as coherent. Confident wrong answers are the natural product of ungoverned semantics. So what does enforcement actually look like? First, data products don't just publish tables, they publish contracts. If a domain publishes customer, the contract specifies what customer means, what active means, what deduplication rules exist, which source systems are authoritative, and what the expected failure modes are. If that sounds heavy, good. It should be heavy because you are publishing meaning at enterprise scale. Second, semantic models are governed artifacts with controlled change. If the definition changes, it is versioned, communicated, and validated against downstream impacts. This is where most organizations accidentally create chaos. Someone fixes a measure and half the board deck changes next morning. That isn't agility, that's uncontrolled change in the decision layer. Third, you establish an arbitration function. This is the part executives avoid because semantic disputes are political. They are budget disputes with nicer vocabulary. But the enterprise needs an explicit authority that can resolve which definition wins and why. If you don't assign an arbitrator, the system will assign one for you. It will be whichever team shipped last. Now, there's a common mistake platform leaders make here. They try to solve semantics with a central team that defines everything up front. That fails too because the center doesn't own domain reality. They create beautiful definitions nobody uses, then teams root around them. The correct model is federated. Domains own their concepts, but they publish them through shared standards, and the enterprise governs the overlaps. You don't need one team to define everything. You need one system that makes definitions enforceable and reusable. And yes, this feels like slowing down. It is on purpose, because the alternative is accelerating ambiguity, and AI is a perfect ambiguity accelerator. So here's the transition. If you lock identity, you control who can see data. If you can audit governance, you can defend where data came from and how it moved. But if you don't lock semantics, you can't defend what the data means. And the first time an AI output becomes a real business decision, meaning is what you'll be asked to justify. Failure scenario A, the Gen AI pilot that went viral. Now let's make this concrete with a failure pattern that keeps repeating because it feels like success right up until it becomes real. A Gen AI pilot goes viral internally. It starts as the cleanest demo you can build. Retrieval augmented generation over enterprise documents, a curated SharePoint library, a handful of approved PDFs, some policies, a nice chat interface. People ask questions and the system answers in seconds. Leadership sees the adoption curve and decides this is finally the breakthrough. And at the pilot stage, they're not wrong. It looks impressive. The answers are fast. The citations make it feel responsible. The UX feels modern. And because the corpus is narrow, the system stays mostly coherent. It even feels safer than reality because the system is consistent inside its small sandbox. Then the adoption happens. The link gets shared, a Teams message, an email forward, a hey, you have to try this. Suddenly the pilot isn't a pilot anymore. It's a shadow production system with executive attention. This is where the enterprise usually makes its first design omission. The document corpus has no named owner. Not IT owns SharePoint, not the platform team runs the connector. A real owner, the person who can say what is in scope, what is out of scope, what correct means, and what happens when something is wrong. Because documents aren't data, they are claims. A policy document says one thing, a procedure says another, a contract says something else. A 5-year-old slide deck says something completely different, and it is still discoverable because nobody wanted to delete it. So the system retrieves, it synthesizes, it answers correctly, under the assumptions you accidentally encoded. And then the first conflict lands. An employee asks a simple question that matters. What's the approved approach for X? The assistant answers with confidence and cites a document. A second employee asks the same question the next day and gets a different answer, citing a different document. Both answers are plausible. Both answers are supported. And now you've created the most dangerous class of enterprise output, authoritative inconsistency. This is where the escalation starts. Not because people hate AI, because people hate being wrong in public. A manager sees an answer that conflicts with what they've been enforcing. They forward it to legal. Legal asks compliance. Compliance asks security. Security asks the platform team. And the platform team is now in the middle of a dispute they cannot solve because it isn't a platform problem. It's a truth problem. The enterprise never decided who owns truth for this corpus. So the pilot freezes, not in a dramatic way, in the enterprise way, until we can review it, until we can validate the content, until we can ensure the right controls. And you'll notice what happens next. The pilot doesn't get improved. It gets paused, the budget gets redirected, the energy moves on to the next exciting prototype. Leadership quietly concludes that Gen AI isn't ready, but the model didn't fail. The enterprise refused to decide what correct means and who gets to arbitrate when two documents disagree. Now here's the part that stings. The viral pilot didn't create the risk. It exposed the risk that already existed. The organization has conflicting instructions, conflicting definitions, and conflicting policies living side by side. Humans cope with that by relying on tribal knowledge and escalation chains. The assistant removed the tribal knowledge layer and returned the raw contradiction. And because it did it quickly, at scale, and with confidence, everyone treated it like a new threat. So what's the executive move that prevents this? Treat the document corpus as a governed data product. That means a named owner, a defined scope, a life cycle. What gets added, what gets retired, what gets flagged as outdated, what gets marked as authoritative. It means classification rules that follow the content and access rules that match the sensitivity. And it means a semantic decision, what questions this corpus is allowed to answer and what questions it must refuse. Because not every enterprise question is answerable from documents alone, and pretending otherwise is how you turn helpful assistant into liability generator. So the lesson is simple. If you can't name the owner of truth, the system will stall the first time truth gets challenged. And it will be challenged. That's not pessimism. That's how enterprises behave when outputs start affecting real decisions. Now, governance failures stop pilots, but economics failures stop platforms. That's next. Failure scenario B. Analytics modernization becomes an AI bill crisis. The second failure pattern looks nothing like a governance panic. It looks like success. An organization modernizes analytics. They consolidate tools. They standardize workspaces. They move toward a unified lakehouse pattern, often with a fabric-style experience. One place to engineer, model, and report. They turn on self-service. They enable AI features. They celebrate because the friction is gone and the backlog starts shrinking. And for a while, it is real progress because unification does remove waste. Fewer copies, fewer pipelines, fewer bespoke environments. Teams stop spending weeks negotiating access to data. Reports light up faster. The executive dashboard actually refreshes on time. Everyone feels like they finally fixed data. Then the bill arrives. Not as a gradual increase, as a cliff. Suddenly, compute consumption spikes. Capacity is saturated, interactive performance degrades, queries queue, background work competes with user workloads, Finance gets a number that doesn't map to a business outcome, and they do what finance always does when the system can't explain itself. They intervene. This is the moment the modernization story flips. The platform team gets asked, why is this so expensive? And the platform team answers with technical truths that aren't useful at the executive layer: concurrency, workloads, burst behavior, and a shared capacity model. All true. None of it is the reason the enterprise is angry. The real reason is simpler. Nobody can connect cost to accountability. No unit economics, no cost owner per outcome, no line of sight from consumption back to decisions. So the only available governance mechanism becomes the blunt instrument: throttle, disable, or restrict. In the Microsoft Fabric model, everything draws from shared capacity units. When demand rises, throttling becomes the platform's way of preserving stability. And from an executive perspective, throttling feels like the platform is unreliable. It isn't. It's doing exactly what the architecture was designed to do when demand exceeds intent. But intent was never enforced. Here's how this failure sequence usually plays out. First, self-service expands faster than governance. Teams create more artifacts, more pipelines run, more notebooks execute, more reports hit the system. None of this is inherently wrong. It's the point of democratized analytics. Second, AI features amplify usage patterns. People iterate more, they ask more questions, they run heavier queries, they experiment. And experimentation is expensive by definition because it trades certainty for exploration. Third, costs become visible to finance before they become understandable to leadership. The bill shows spend, not value. It shows compute, not decisions. It shows capacity usage, not outcomes. So finance escalates. Then comes the executive directive that kills trust. Turn it off until we understand it. And now the platform is stuck because you can't build adoption and then remove it without creating organizational backlash. Teams stop trusting the platform. They root around it. Shadow tools reappear. The modernization effort starts to unravel into the same fragmentation you were trying to escape. The lesson is not unified platforms are expensive. The lesson is, without unit economics, unified platforms are uncontrollable. If the organization can't describe cost per decision or cost per insight, then every cost discussion becomes political. One team claims they're doing valuable work. Another team claims they're paying for someone else's experiments. Nobody has a shared measurement system to arbitrate. And because AI workloads are bursty and variable, the bill will never be stable enough to ignore. Cost surprises are architecture signals, not finance failures. They tell you the system has missing boundaries. So what is the executive move that prevents this? Make cost a first-class governance surface, not a quarterly surprise. And that means every AI-enabled workload needs a cost owner, not it owns the bill. A named owner tied to an outcome: case resolution, fraud review, customer support deflection, contract analysis. If there's no outcome, there's no owner. If there's no owner, it's a lab experiment. Treat it like one. Then define one unit metric per use case that survives vendor change, not cost per token. Tokens are implementation detail. The metric is cost per decision, cost per insight, or cost per automated workflow. Something leadership can govern without learning model internals. When leaders can see the unit economics, the conversation changes. You stop arguing about platform spend, you start managing decision economics. And once you do that, the platform becomes fundable, because the enterprise can decide deliberately what it is willing to pay for. Without that, the platform will always hit the same endpoint: finance intervention, throttling, and a slow collapse of trust. And once trust collapses, the next instinct is decentralization, which solves bottlenecks and then creates semantic chaos. That's next. Failure scenario C. Data mesh meets AI and produces confident wrong answers. The third failure pattern is the one that hurts the most, because it starts as the correct organizational move. The centralized data team was a bottleneck, so leadership embraces domain ownership. Teams publish data products. They document things, they set up domains. Everyone says the right words: federated governance, data as a product, self-serve platform. And for a while, it looks like maturity. Domains ship faster because they're closer to the work. They know their systems. They know their edge cases. They can iterate without waiting 3 months for the central backlog to move. Then AI arrives and asks the question that data mesh alone doesn't force you to answer: are your meanings compatible? Because AI doesn't stay inside a domain boundary. The whole point of AI is cross-cutting synthesis. Customer support questions touch product, billing, identity, compliance, and entitlement. Fraud touches transactions, device signals, and customer history. Supply chain touches inventory, orders, logistics, and finance. The model will traverse domains because the decision traverses domains. And this is where the system produces confident, wrong answers. Not because the model hallucinated, because the enterprise published conflicting semantics at scale. Here's what it looks like. Domain A publishes customer and means an entity with an active contract in system A. Domain B publishes customer and means an entity with a billing relationship in system B. Domain C publishes customer and means any person who created an account regardless of contract or billing. All three definitions are defensible inside their own boundary, and all three are incompatible when you build cross-domain decisions. Now add AI, you build a retrieval layer over these data products, you train or ground the model across them. You build an assistant that can answer questions like how many active customers do we have? Or which customers are eligible for X? Or what's our churn risk? The model sees multiple patterns. It sees multiple meanings. It doesn't resolve the conflict. It learns the distribution. So you get an output that sounds coherent, cites sources, and is still wrong. Not because the sources are wrong, because the synthesis assumes the enterprise has one definition when it has three. This is the most dangerous failure mode in AI, correctness theater. The output looks professional, it's fast, it might even be numerically consistent with one data set, but it is semantically wrong for the decision the business thinks it's making. And the business will detect it quickly because the business lives in consequences. The number doesn't match what finance reports. The eligibility list doesn't match what operations sees. The assistant tells a support agent one thing and the billing system enforces another. People stop trusting it. And the platform gets blamed. This is where the narrative becomes predictable. Leaders say data mesh didn't work, or AI isn't reliable, or we need a better model. No, you need semantic governance. Decentralization solved the delivery bottleneck, but it decentralized meaning, and meaning cannot be decentralized without contracts because the enterprise is not a set of independent startups. It is one legal entity with one balance sheet. At some point, someone must be able to say, this is the enterprise definition. This is why semantic disputes are executive work. They are not technical disagreements. They are boundary disputes. They affect reporting, incentives, and accountability. If you leave them to teams, teams will optimize locally. If you leave them to the platform team becomes the political referee for the business. That's not scalable and it's not fair. So the fix is not go back to centralization. The fix is federated governance that standardizes semantics while preserving domain autonomy. Domains can own their data products, but they must publish semantic contracts that meet enterprise standards. The enterprise must endorse and certify shared definitions. And when two domains disagree, you need an arbitration pathway that resolves the conflict deliberately with a decision record and controlled change. Because once AI is in the loop, ambiguity becomes operational risk, and the executive move is simple to say and hard to do. Do not allow everyone builds their own semantics. Allow domains to build their own pipelines. Allow them to own their own products. Allow them to move fast, but enforce shared meaning for shared decisions. Otherwise, you will scale ambiguity, and AI will do it politely, confidently, and at machine speed. Now, you might be thinking this sounds like governance overhead. It is overhead. It's the overhead that replaces rework, distrust, and incident reviews. Because the alternative is spending that same effort later, under pressure, when the business already lost faith. So the lesson from this failure scenario is blunt. Data mesh without semantic contracts doesn't create agility, it creates scalable confusion. And AI turns scalable confusion into automated decision damage. Once you've seen that, you can predict the next break. Governance failures stop pilots, economics failures stop platforms, semantic failures stop adoption. And all three happen faster when AI is involved. Economics of AI cost as an architecture signal. Now, the part everyone pretends is boring until it becomes urgent, economics. AI workloads are variable, bursty, and expensive by nature. That isn't a vendor problem. That's the physics of running probabilistic systems at scale. You pay for compute, you pay for retrieval, you pay for storage and movement, you pay for evaluation, and you pay again when you iterate. And iteration is the whole point. So if your organization treats cost spikes as a finance surprise, you've already misframed the problem. Cost surprises are architecture signals. They tell you where the operating model is missing boundaries, where usage is unconstrained, where ownership is undefined, and where self-service became unpriced consumption. That distinction matters because enterprises don't shut down platforms when they're expensive. They shut them down when they're unpredictable. Unpredictable spend is interpreted as a lack of control, and control is what executives are paid to provide. This is why unified platforms change the cost conversation in uncomfortable ways. In Microsoft Fabric, for example, you're operating a shared capacity pool. Everything draws from it: engineering, warehousing, notebooks, pipelines, reporting, and the AI-adjacent workloads that ride on top. That shared pool is a feature because it reduces fragmentation, but it also forces prioritization, which means you either design cost governance up front, or the platform will impose it later through throttling, backlog, and internal conflict. The platform doesn't care about your org chart. It cares about contention. So here's the reframe leaders need to internalize. When your AI bill spikes, don't ask who ran up the bill. Ask what design omission allowed this to happen without a conscious decision. Because there is always an omission: missing ownership, missing quotas, missing prioritization, missing unit economics, missing enforcement. And it's not just compute. AI costs arrive through multiple pathways that enterprises underestimate. One bursty usage, a pilot becomes popular and suddenly the concurrency profile changes. 10 people test it, then 100, then 1,000. Costs don't scale linearly because demand doesn't scale linearly. Demand spikes. 2. Hidden background work. Platforms do useful maintenance tasks. Optimization, refresh, indexing, caching. Those are real workloads. If you don't see them, you can't account for them. And if you can't account for them, you'll blame the wrong thing when the numbers move. 3. Experimentation. AI work is not a steady-state factory line. Teams test prompts, models, retrieval strategies, and evaluation runs. If you treat experimentation as free because it's innovation, the enterprise will pay for it in the least controlled way possible, uncontrolled consumption. So the hard requirement becomes convergence. FinOps, DataOps, and MLOps cannot stay separate disciplines. If FinOps only sees invoices, it arrives late and with a blunt instrument. If DataOps only sees pipelines, it optimizes throughput but not economics. If MLOps only sees models, it optimizes quality but not sustainability. They must converge into a single operating discipline, the ability to ship AI-driven decision systems with predictable cost, observable quality, and enforceable governance. And this is where cost visibility becomes part of platform trust. And if teams can't predict what a feature will cost to run, they will stop shipping, not because they're lazy. Because every deployment becomes a budget risk and nobody wants to be the person who caused the finance escalation. So the platform has to provide a cost model that is legible, not CUs and tokens and capacity utilization graphs, although those matter for engineers. Legible to leadership means the cost aligns to outcomes. Because the only sustainable funding model for AI is outcome-based accountability. If you can't tie spend to outcomes, you will either overspend silently or get shut down loudly. Now, there's a trap here. Some leaders respond by trying to centralize all AI usage, thinking control equals central approval. That creates a different failure, bottlenecks, and shadow usage. People root around controls when controls prevent work. Governance erodes. Exceptions accumulate. Costs still rise, just in less visible places. So the correct pattern is not centralize, it's price and govern. You want usage to be easy, but not free. Easy with guardrails, quotas, tagging, workload separation, prioritization, and explicit ownership of the cost of a decision loop. If a workload cannot name a cost owner, it isn't production. It's a lab. Treat it like a lab. And that's the executive insight. Cost is not a metric you look at after. Cost is a design input. It tells you how you must shape architecture. Caching versus live retrieval, batch versus real-time, shared capacity versus isolated pools, and how you measure the value you're buying. AI is not expensive because it's new. AI is expensive because it accelerates demand, and demand without boundaries becomes debt. So the next move is to make those boundaries visible in a way leadership can govern without becoming model experts. That means unit economics that survive vendor change. Unit economics that survive vendor change. So now the enterprise needs a cost language that doesn't require everyone to become a cloud billing expert. Because if the cost story is CUs went up or token spend spiked, you've already lost the room. Those are implementation details. They matter to operators, but they don't survive platform evolution, vendor negotiations, or even your next architecture refactor. Executives need unit economics that are stable. Stable means you can change models, change tooling, change platforms, and still measure value the same way. And the simplest move is to stop talking about AI spend and start talking about cost per outcome, cost per decision, cost per insight, cost per automated workflow. That distinction matters because the enterprise doesn't buy models. It buys behavior at scale, shorter cycle times, higher consistency, lower error rates, fewer escalations, fewer manual reviews, faster resolution, lower cost to serve. So here's the test for your unit metric. If you can't explain it to finance, you can't govern it. If you can't explain it to the business owner, you can't fund it. If you can't explain it to the platform team, you can't operate it. The thing most organizations miss is that unit economics is not a dashboard. It's a contract. It defines what success costs and who absorbs variability when reality changes. Now let's anchor this in a concrete example. AI-assisted case resolution. The enterprise spends $120,000 per month on the AI-enabled workflow. That spend can include model inference, retrieval, platform compute, observability, and the plumbing you never put on the PowerPoint slide. That system produces 60,000 decisions per month. Decisions, not tickets. A decision here is a classification, a routing, a recommendation, or an eligibility outcome that drives action. So your unit economics are simple. $120,000 divided by 60,000 decisions equals $2 per decision. Now, the first reaction from a lot of leaders is to argue about what counts as a decision. Good. That argument is the beginning of governance. Because if the organization can't agree on what the unit of work is, it can't agree on value either. And AI investments without a unit of work are always justified with vibes. Now compare that to a human-only baseline. Let's say the human process costs $18 per case, with a 24-hour average resolution time. That cost includes labor, rework, escalations, and the hidden operational overhead that never shows up in the AI business case deck. With AI-assisted resolution, the decision cost is $2, the resolution time drops to 5 minutes, and humans review 10% of cases for oversight and exception handling. This is the executive framing that matters. You didn't buy AI, you bought cheaper, faster decisions with human oversight. And that framing survives vendor change because it doesn't depend on which model or which feature. If you change from one model provider to another, your unit metric stays the same. Cost per decision at an acceptable error rate with a defined review pathway. Now, there are two non-negotiables when you adopt unit economics. First, you need to attach an owner to the unit. Someone must own cost per decision for that workflow. Not IT, not the data team, not the platform. The business owner who benefits from the decision throughput is the owner because they control demand and accept the risk. If the business owner refuses ownership, the use case is not real, it's tourism. Second, you need to include the cost of governance and trust. Most AI ROI stories cheat by ignoring the cost of controls. Evaluation runs, logging, prompt versioning, access reviews, red team testing, incident response, and the inevitable remediation work when a decision loop drifts. Those costs are not optional overhead, they are the price of making probabilistic systems safe enough to operate in an enterprise. So don't hide them, price them. Because anything you cannot price eventually gets shut down. Now, a quick warning. Unit economics does not mean you optimize for the cheapest decision. That's how you get unsafe automation. Unit economics means you optimize for an acceptable decision. Cost, speed, and quality bounded by governance. It's a trade space, not a race to zero. And once you have that unit metric, you can do real architecture. You can decide where caching belongs, where retrieval belongs, where batch scoring belongs, where real-time inference belongs, where you need isolation versus shared capacity. You can justify guardrails without sounding like a compliance committee. Because now every guardrail has an economic purpose. It protects unit economics from turning into an outage, a cost spike, or a trust collapse. This is where leaders get leverage. If you remember nothing else, don't govern AI by platform spend. Govern AI by unit economics, because platforms change. Operating models must survive. Operating model design, decision rights enforcement, and exception pathways. Now we get to the part everyone wants to skip because it sounds like process. It isn't. It's the control plane of your enterprise. The foundational mistake is thinking intent becomes reality because someone wrote it down. Intent is not configuration. Configuration is not enforcement. And enforcement is the only thing that survives scale. Over time, policies drift away from intent because the enterprise optimizes for shipping. Every temporary access grant, every unowned dataset, every unofficial metric definition, every just this once exception becomes an entropy generator. They accumulate. Then AI arrives and turns that accumulated drift into real-time decisions. So if you want this to survive 3 to 5 years, you need an operating model that treats drift as inevitable and designs for it. Start with decision rights. Not who does the work. Who has the authority to decide and who is accountable when reality doesn't match the decision. You need a map, 1 page, brutally explicit. Here are the decision rights that matter, and if you leave any of these undefined, the system will pick an owner for you. It will pick the person who answers the escalation call at 2 a.m. quality owner, the person who sets acceptable failure modes for a data product and funds the fix when quality drops. Not the platform team, the domain owner who benefits from the decision. Semantic owner, the authority for meaning, the person who can say this is what active customer means and can approve changes without turning the enterprise into a weekly reconciliation meeting. Access owner, the person who approves who can read what, for which purpose, and for how long. This is where the enterprise either designs deterministic access or accepts conditional chaos. Cost owner, the person who is accountable for unit economics. If cost per decision doubles, this person owns the response. Not finance, not IT. The outcome owner. Exception authority, the person who can approve exceptions with a time limit and can be held accountable for the risk they just accepted. That's the map. Now the part that separates functional operating models from PowerPoint enforcement mechanisms. Most enterprises create policies and then outsource enforcement to human discipline. That is a fantasy. Enforcement must be mechanized. Identity gates, entra-based access patterns that force least privilege and make access grants expire by default because we'll clean it up later, is how you create permanent drift. Classification and lineage, governance surfaces like Purview that make data traceable by default, so audits are evidence retrieval, not archaeology. Semantic certification, a mechanism to publish endorsed definitions and prevent everyone builds their own from becoming the default behavior. If it isn't endorsed, it isn't used for enterprise decisions. Cost guardrails, tagging, quotas, capacity boundaries, and visibility that prevent spend from becoming an after-the-fact argument. If you can't see it, you can't govern it. And here's the uncomfortable truth. You don't get to decide whether exceptions exist. Exceptions are inevitable. You decide whether exceptions are controlled or invisible. An exception pathway is not bureaucracy. It's damage containment. Without an exception pathway, people will still get exceptions. They'll just do it through informal channels. Someone knows someone, a role gets assigned temporarily, a workspace gets shared, a dataset gets copied, and now the exception is permanent because nobody recorded it. So design the pathway deliberately. Every exception needs 4 attributes. 1, who approved it. 2, what it grants. 3, why it exists. 4, when it expires. And if you want to be serious, add a fifth. What compensating control exists while the exception is active? Logging, additional reviews, reduced scope, explicit monitoring, something. This is where executives and platform leaders usually misalign. Executives want speed, platform leaders want safety. Both are rational. The operating model reconciles them by making exceptions a first-class capability, fast when justified, bounded by time, and visible to the people who carry the risk. Here's a simple operational signal that tells you whether you built this correctly. If an incident happens, can you point to the owner in seconds? If not, the system will stall in hours. Because every escalation becomes a meeting, every meeting becomes a debate, and every debate becomes delay. Then the enterprise concludes the platform is slow. It isn't, your decision rights are missing. So the transition is straightforward. If you can define decision rights, enforce them mechanically, and treat exceptions as governed pathways, you now have an operating model that can absorb AI without breaking trust or budgets. And that is what future-ready actually means. What future-ready actually means. Most enterprises use future-ready as a comforting synonym for we picked the right vendor or we bet on the right model. They are wrong. Future-ready is not predicting the next model. It is absorbing change without breaking trust, budgets, or accountability. That distinction matters because AI progress is not linear. It arrives as discontinuities, a new model class, a new regulatory interpretation, a new attack pattern, a new business demand, a new cost curve. If your operating model can't absorb discontinuities, your strategy is just a slide deck with a shelf life. So what does future-ready look like in operating terms? First, clear ownership. Not we have a team. Named humans attached to decisions. Who owns data quality? Who owns semantic meaning? Who owns access approvals? Who owns unit economics? Who owns exceptions? If you can't name the owner in seconds, you don't have an operating model. You have an escalation loop. Second, platform as product. The data and AI platform isn't a migration. It's a durable capability with a roadmap, service levels, and an explicit cost model. The platform team is not a help desk. They are the owners of the shared system that every domain depends on. That means they need authority, not just responsibility. Third, governed data products, not raw storage, not a lakehouse with tables. Data products with owners, consumers, semantic contracts, quality signals, and access policies that are enforceable. AI doesn't consume your storage layer. It consumes whatever you let your organization treat as truth. If truth is unowned, AI will expose it. Fourth, observability as default behavior. If you can't see what data was used, what changed, which model version ran, what prompts were active, what retrieval sources were hit, what filters were applied, and what it cost per unit of work, you are operating blind. And blind systems don't scale. They just accumulate mystery until someone turns them off. Fifth, continuous learning loops, not in the motivational sense. In the mechanical sense, business outcomes feed back into data products. Data products feed back into the platform. Platform telemetry feeds back into governance. AI outputs feed back into evaluation and tuning. That loop is what keeps a probabilistic system from drifting into confident wrongness. And here's the core executive takeaway. Future-ready means every missing boundary becomes an incident later. If you don't define ownership, you'll get escalation paralysis. If you don't define semantics, you'll get inconsistent decisions. If you don't define access, you'll get data exposure. If you don't define cost, you'll get finance intervention. If you don't define exceptions, you'll get invisible drift. So future-ready is not a maturity score. It's an absorptive system. The enterprise that wins is the one that can adopt new models, new capabilities, new tooling, and new workflows without relitigating trust every quarter. Because trust is the bottleneck, not model quality. And that's why the most valuable design work isn't choosing services. It's designing the operating system those services run inside. Closing reflection plus 7-day action. Azure AI amplifies whatever operating model you already have. So fix the model first, or AI will expose it. In the next 7 days, run a 90-minute readiness workshop and produce 3 artifacts: a 1-page decision rights map, decision, owner, enforcement, 1 governed data product with a named owner and semantic contract, and 1 baseline unit metric like cost per decision. If you want the follow-on, the next episode is operating AI at scale, lifecycle, governance automation, and cost control.